All right, we're going to look at the binomial probability distribution tool within the statistical toolkit. Now, what's critical is that you be able to recognize when you're encountering a binomial probability distribution problem. And these problems have four key characteristics. Number one is that there are n identical trials. Now, a trial could be anything. It could be flipping a coin, it could be inspecting a part, it could be turning left or right. But it has to be identical. Secondly, the trial can only have two outcomes, hence the term binomial. Only two possible outcomes. And we call those outcomes a success or a failure. And you can define a success as being anything you want it to be. A success could be finding a defective part. That success has some probability that you assign to it. Or it could have a probability based on the nature of the phenomena, whatever that might be. In the classic case, flipping a coin, as long as it's a fair coin, has two possible outcomes, and the probability of a head or a tail would be 50% or 0.5. And the other key characteristic is that all the trials have to be independent. In other words, the outcome of one trial doesn't affect the outcome of the next trial. So the problem that we're going to use as a demonstrator is the problem that asked, in a family of 5 children, what is the probability of having 3 or more boys? So the wording of the problem defines a success as having a boy. We could just as easily define a success as having a girl. So we're going to have 5 children. So the number of trials is 5. The probability of success in this case is 0.5. So the way this tool is set up, for each individual x value, it calculates the probability that x is exactly one of these values that you select. So the probability that x is 0, in other words, the probability that we have no boys, is 0.03125. The probability of having exactly one boy, 0.15625. 2 boys, etc. And what's interesting is that you see that the probability of having 5 boys is the same as the probability of having no boys. So it's symmetrical in that respect. The second column shows you the cumulative probability. So this is the probability that x is going to be less than or equal to one of these values. So, for example, the probability of having one boy or less, in other words, either one or no boys, is going to be the sum of these two values, sum of the 0.03125 plus 0.15625, which is 0.1875. And the cumulative probabilities are simply the sum of that particular value of x plus all of the successive probabilities, all the preceding probabilities, let's say. The tool also calculates the expected value, which is simply the number of trials multiplied by the probability of success. If we take that expected value and multiply it by 1 minus the probability of success, that gives us the variance. And if we take the square root of that variance, that gives us the standard deviation. This third column of probability is simply taking the cumulative probability and subtracting it from 1 to give you the probability that x is strictly greater than that corresponding value of x shown in the first column. So using this, once you know you have a binomial probability distribution, the problem that we were looking at is the probability of having 3 boys or less. So that would be 0.8125. The probability of 3 boys plus the probability of all the preceding number of x values.